Hello everyone, I'm Carl Zielinski, and today I thought I'd show you how you can minimize the number of draw calls in your 2D Raylib game. So this game currently running here has some tiles and an animated character, and it also has this unique object here, and it has some text, and it has this red shape that is drawn here. And all this is currently drawn using a single draw call. This means that the code that is telling the GPU to actually draw stuff on the screen only tells the GPU to do it once. And having few draw calls leads to less overhead. Many games that have sort of performance problems often run into those because of having too many draw calls. So it becomes like a bottleneck for the game. So how does this work? Like, how do you get less draw calls? In Raylib, a draw call, you usually get a sort of a new draw call if you switch camera, or if you change shader, or if you change texture. So if you have the same shader on and you're inside the same camera and you use the same texture, then those things will sort of collapse down. Raylib will batch it up automatically for you to become a single draw call. So the texture part here is key, because it's quite easy to use the same camera for everything, and it's quite easy to use the same shader for everything. But having everything in your game within a single texture can be a bit tricky to achieve. These kind of textures with everything inside them are usually called atlases. Let me show you how my atlas looks. So here is the atlas that I'm using. As you can see, this sort of bushy thing here is there, and then there's some different animation frames, and then there's also the letters from the text that you can see here. And it's also actually there's a white square somewhere in here. There it is. That's the Raylib shape drawing texture, so that you can draw also shapes using this texture as well, so that you can use one texture for sort of drawing everything. Now, what this means in practice is that whenever you want to draw something in the game, you are always using the same texture constantly, but you are looking within a small rectangle of it. So maybe if you want to draw this animation frame, then you're looking into this rectangle. If you want to draw this letter, then you're looking into this rectangle, but you keep using the same texture. So for example, in this game, the world is made up by lots of small tiles, and those are all drawn using the atlas. So here's my tile draw procedure, and it says draw texture rectangle, and then it feeds in the atlas. This is just a global variable, but it has the atlas texture inside it. And then it has a rectangle of where to pick inside that atlas. And those rectangles comes from like this list here called atlas tiles. We'll look at this shortly, how I generate this atlas tiles list, because I generate this kind of list for tiles and for animations and for textures and all that. I have different lists for those. So let's look at how we actually generate the atlas, and then we'll come back and look at these sort of arrays of rectangles that lets us just draw things from inside the atlas. So in the folder for my game, I have this program called Atlas Builder that I've written that builds the atlas file. And what that program does is that it opens this textures folder, and it looks in here, and here you see, here is the bush and the player character, and there's some button over here. And then we also have over here the tile set. So it looks inside this folder and takes those things and puts them into this sort of atlas texture, and then also records some metadata of where it actually put it, so that you can use that. So the atlas texture is outputted here, atlas.png, but then the metadata is actually just another Odin file. So I have inside my game folder here, it outputs atlas.odin, and this atlas.odin file that it outputs contains all the data of where the textures are in it, where the tiles are in it, and all the letters from the font, because I maybe forgot to mention that, but there's also a font.ttf here, and it opens these TTF fonts and picks out a selection of letters that I have configured it to pick out and puts those into the atlas as well. So in this generated atlas.odin file here, I have, for example, these button 0, 1, 2, 3, 4, 5. That's the different frames of this button animation here. So if we open this button animation here, we see that it has 6 different frames that are also sort of split up into 3 different tags, so that I actually have 3 different animations. One for if the button is just idling, or if it's moving in, being pressed, or if it's actually pressed. So that's 3 separate animations. And I also generate sort of the metadata for keeping track of which animations exist in the animation. Well, yeah, which sort of sub-animations exist within the Sprite file, I should say. So it's pretty neat in the way that I'm able to work directly in Sprite files. It also supports PNG, but it supports Sprite files and animations and all that, which makes it much nicer to work with for me. The workflow is very nice. So it has the list of all the textures. That's essentially all the just plain texture files or frames from animations. And then it has a list here called Atlas Textures, which is just an enumerated array between the texture name and the Atlas texture. And that's sort of like and this Atlas texture thing, the important thing here is perhaps the rectangle here. That's where inside the Atlas this texture exists. And if we scroll down a bit more, here we have Atlas glyphs. These are all the letters that it picks out from the font. So you have the rectangles of where the letters are and which actual letter each is. And what you should notice here, that this is atlas.odin file. What my build system does is that it runs the Atlas builder before it builds the game. And then it outputs the atlas.odin file into the game folder, and then it builds the game. So the game has sort of you can reason about these texture names and stuff while in your code. It doesn't have to be something you wait until runtime to sort of resolve and load a file. You know that this animation exists because it's part of atlas.odin that is compiled as part of my game. So we're sort of generating this atlas.odin file and the PNG file just before it actually compiles the game, so that I can use these symbols within there. So you have the Atlas glyph, and then you have also the tiles. And the tiles, I just pre-generate a big list of tiles, more than I have in my tile set, just for making it a bit future-proof. And then for the tiles that actually exists within the tile set, I say which rectangle is it on inside the atlas. And these rectangles is just like, this is X position, Y position, width and height. So you see all these tiles are actually 8 by 8 pixels. So you may wonder, how does it know that, for example, this button or player thing here is an animation, but this is a tile set? What I do is just that I look at the prefix of the file name. I write tileset _, and then it's gonna just use that as the tile set to output this kind of data instead of trying to output it as a texture or something. And then we have animations, and animations are, the animation name comes from either the file name, for example, in the case of the player, in this one, if we open it, there's only a single animation. There's no tags here in the timeline, right? But in the case of the button, we had 3 different tags. So here you see pressable. So this is button pressable. And if we look in the animation names here, we have button _ pressable. So this enum name is generated from the file name of this thing here, plus the tag inside the animation, so that I can extract 3 different animations from one Sprite file. And then we have another enumerated array, Atlas animation. It maps from animation name to Atlas animation. And an Atlas animation just says which is my first frame and which is my last frame, and then it has some extra stuff. So since my texture names are sorted in the sort of alphabetical order, and then there's just a number at the end that is the frame, then I can actually use these sort of as a range. So I can say this is the first frame and this is the last frame. And then when animation plays later in the game, it can just be like, okay, I'm on this one. Now I have passed enough time to go to the next frame. And by the way, that it knows how long each frame is. So it can extract that from the file as well. It's stored inside the Atlas texture, regardless of if it's an animation or not. There's a dummy value there if it's not an animation. But for example, with this button here, the pressable is the first 3 frames. That means that the pressable animation would go from button 0 to button 2. So if we go back down and look at that, then we see here button pressable has first frame button 0 and last frame button 2. And then it just also outputs the file name of the Atlas and how big the font size of the text in it is and which letters are actually present in the Atlas. So the way I use this in my game is just that I load the Atlas like this, load texture Atlas file name, and this is just a constant, and this constant is available because it comes from the atlas.odin file, which is in the same package as the game.odin file. So I can just use this constant here. So it loads that one, that way it has the Atlas, and the font comes from, currently it says editor font. That's because I mainly use that font in the editor of the game right now. But it sort of reconstructs a Raylib font using the list of glyphs inside the Atlas.Odin. Atlas glyphs here is the global array that's available inside Atlas.Odin. This one, Atlas glyphs, it goes over it here and sort of records where all the rectangles is and prepares all the data for Raylib so that it can create a Raylib font. But this Raylib font actually, for the texture, uses the Atlas. It does not use sort of a separate texture for the font. And then also I also save out inside the Atlas.Odin the shapes texture rect. That's where the little square, that's where this white square is, the shapes texture rect, and that's a thing it just uses to draw. When it runs draw rectangle, draw circle, and all that, it can use this sort of white rectangle to draw them, so that it can do that in the same draw call as well. So this Atlas Builder program then that generates the Atlas and the Atlas.Odin file is a program that is built from the stuff inside this Atlas Builder folder here. And this stuff in this folder is available in my Odin Raylib hot reload template that is linked in the description. You can find it on GitHub. So the way this little build pipeline works is that whenever I want to build my game, first I run, this builds and runs the Atlas Builder, and since that will output the game.odin file, then when it later runs build game, then that one will use the metadata in the atlas.odin file. So that's sort of this is sort of like a pre-code and picture generating step in a sense. So if you go into the code that I have linked in the description for the builder, then I can just quickly say what it does. So it comes with this Sprite loader package that is by the Odin community member called Blob. But within atlasbuilder.odin, there are some things you can do to configure it. You can set the Atlas size. You can set the width of the tileset if you use a tileset. If there's no tileset file, I think it will still work. It will just not generate the tileset things. You can say how big the tiles are. And then you can change the package name of your game because it needs to have the atlas.odin file needs to have the same package name as the rest of your game stuff. And then which directory to look for textures inside. And this is which letters to pick out from the font.ttf. And this is the TTF font it will load. So that's how you can configure it a bit. And if you download the template, that I mentioned, then it will be by default disabled, so you will have to go into build hotreload.bat or the shell script if you're on Mac or Linux and sort of enable the lines for Atlas Builder and maybe create a textures folder as well. But it's all there for you to study and see how you can do something like this yourself. I'm not going to go too deep into how the actual Atlas Builder works, but I can just quickly say that it uses the ASprite loader to load the ASprite files or the PNG loader that comes with Odin. Then it uses the STB recpack stuff within the vendor collection to do the actual packing of rectangles, so it knows where to put them in the Atlas texture. And when it has figured that out, then it can sort of output the image to disk. And then finally it also does some bookkeeping to keep track of where in the Atlas did it put things, so that it can generate the atlas.odin metadata stuff. And the way the atlas.odin file is generated is simply that it just prints Odin code like this. Here you see here's the Atlas texture name. It goes over all the different things it has found in this textures folder and stuff, and just outputs it. Odin is such a simple language that it's actually quite easy to generate code using simple print statements like this. But in general, this Atlas Builder is just a simple Odin program with a main proc like any other Odin program, but it looks inside the textures directory and starts doing all these things and then outputs the atlas.png and the atlas.odin file. So now if we just come back to this tile draw thing that I showed early on here, so the way it gets the Atlas rectangle here that it uses to draw with the Atlas is just that it fetches it from Atlas tiles, and this is just one of those arrays that's available within the generated data. It's this one, Atlas tiles, this one. So it just fetches it from there. And in my tile struct I have here, it just keeps which position and which tile, and the tile ID is then one of these guys. So that's how I store my tile data in my game. But that's up to you to however you want to do it in your game. Let's now look at how you can check how many draw calls you actually have in your game. And we will do that using RenderDoc. So this is RenderDoc, and I have pointed out my executable path here to my game.exe, and I can click launch. So with RenderDoc running now, it says up here, press F12 to capture. So I press F12, and if I then go back to RenderDoc, I see that it has captured a frame here. If I double click that and go inside, then I see here on the left, I see sort of what the computer instructed the GPU to do in order to draw this frame. So if we switch to the texture view here, this tab, and we click on GL clear here, this is when it clears the whole screen with the background color. You see here, this is the back, this is the destination of this is the back buffer, which is sort of what it's drawing to. And then after the GL clear, there is a single GL draw elements. And if we click that, then we see that everything appears all at once. And then it does the double buffering buffer swap. So that's all there is to the whole frame. Now it's not that important to keep it at a single draw call. If you have 2 draw calls, 3 draw calls, 10, it's all fine. It's when it starts, going crazy that your game can really start to slow down. But it's nice, to at this point have it with a single draw call, so that later I know at least that maybe my game will only use no more than 10 draw calls. It will be fine no matter what. And we can look at some limitations of when new draw calls would be introduced. And I said at the start that with Raylib, when you use Raylib 2D stuff, it's usually if you switch camera, shader, or texture is some of the things that can trigger a new draw call. And that's sort of because when you change one of those things, it can no longer batch things together when it's sending it off to the GPU to draw it. So currently it just tells the GPU to draw everything once with 2000 drawing indices here. So here's one way where you could end up getting an extra draw call. So you see here I end mode 2D. So this is sort of where my 2D camera ends. So if I move this text that was on the screen that said single draw call, and also this red block that was on the screen, if I move those outside, then I'm no longer drawing those within the camera, which at the end here, at the end mode 2D, it will sort of submit all the batches and stuff. So this will have to go into a separate batch in a sense. So if we now relaunch the game using RenderDoc, recapture, and double click this frame, we see that the text got very tiny up in the corner here. That's just because it's no longer drawn with the game camera. So it got tiny and the little red dot is super tiny up here. I mean, you can see it if we make this bigger maybe. Oh, it's behind the RenderDoc text. Anyways, it's up here in the corner, the text. Anyways, the important things to notice here is that first we clear the screen, then we draw the whole game, but you see there's no text in here. And then when we click this one, we see that the text appears up in the left corner. So those things ended up in a separate draw call. This is a draw call and this is a draw call. And that's what we sort of wanted to minimize, right? By doing this, you got an extra draw call. But like I said, it's no big deal if you have a bunch of draw calls. It's just that you don't want thousands of them, but you easily get thousands when you have a game where you draw everything using totally separate textures. So it's a fun experiment to try to get it down to one to see if you can do it. But as long as you have almost your whole game in 1 or 2 or 3 atlases, then you're probably fine. So something that might introduce a new draw call is, for example, if you want to have a UI, the UI has a totally different camera because the world camera is looking around the world and the sort of UI should be fixed on the screen, not move around. So those maybe shouldn't use the same camera. Also maybe for scaling reasons, you want the UI differently scaled and stuff. So those might use different cameras. So those would end up in 2 separate draw calls. Also keep in mind that even if you have, say that you have 2 different shaders and everything is in the same texture, but you have 2 different shaders, but you switch shader every other object, then you will still get a lot of draw calls because every time you switch shader, it has to submit the batch, you know. So you also have to sort of draw things in the right order. That's why the UI example is sort of neat, because you can draw the whole game first with one camera, and then you can go to your UI camera and draw the whole game using that one. So that will just be 2 draw calls. But if you do a lot of switching of shaders and stuff within your game camera, then you could still get a bunch of draw calls. So you just have to be a bit aware of how you set that up. Thank you so much for watching. And also thanks to my patrons, which are these people. These people support me on Patreon by giving monthly donations so that I can keep making these videos. And I want to make a super extra shout out to my super supporters that donate $20 a month. And they are Cody Green, Ian Seckington, Mihails Mozajevs, and player Nathan. If you want to support me, then you can become a patron. There's a link to that in the description. And you can also use the super thanks button just beneath this video if you want to give me support that way. That's it. Have a nice day, happy programming, and bye bye.